Welcome back, dear students. So already we have undergone a theory session in gasification. Now in this session we will be focusing on solving problems. So this is the first problem, gasification. A biomass has following composition on mass basis: carbon 37.5 percentage, hydrogen 8.8, so oxygen 27.6, nitrogen 0.4, sulfur 0.1, moisture is 20.5 percentage, and ash is 5.1 percentage. If the above biomass is gasified in a fluidized bed gasifier, what will be the composition of syngas? And when the biomass to oxygen ratio is maintained as 0.8 mass by mass basis, and steam to biomass ratio is maintained as 0.1 mass per mass basis, and also assume carbon dioxide to hydrogen ratio in syngas as 2:1, that is volume per volume, and ignore the presence of other impurities, and consider the molecular weight of ash as 56. Also calculate the yield of hydrogen and carbon monoxide, and why the carbon monoxide and hydrogen content is low, how it can be improved. So this is a typical problem that can be asked in gasification. So here you can see the mass percentage of biomass is given: carbon, hydrogen, oxygen, nitrogen, sulfur, moisture, ash, etc. And this biomass is gasified. So we have already seen gasification can be done with air, oxygen, steam, or a combination of this. And in this it is specified that the biomass to oxygen ratio is specified. That means oxygen will be used as one oxidant, and similarly here steam is also specified. So steam and oxygen are the agents used here, and their ratio mass per mass base of biomass is given. And one more thing, the clue is given is the syngas contains 2:1 volume of carbon monoxide and hydrogen. That is, the volume of carbon monoxide is double that of volume of hydrogen gas in the syngas. So these are things given. So in typical problems we have to solve step by step. So first we know that we have to find out the molecular formula of biomass from this mass basis data given. And we have to, first step is we have to find out the molecular formula of biomass. Then second step is we have to write the chemical equation of gasification based on the data given. And we have to balance on both sides all the elements, carbon, hydrogen, etc. And we will get a number of equations and solve that equation using this incorporating this clue also. So like that we can find out the syngas composition. So that is the step. So first we have to find the molecular formula. So for that we have to consider 100 gram of biomass. Similar problems we have done in combustion also. So for 100 gram of biomass we have to find out the molecular formula. So carbon is 37.5 gram. In 100 gram the carbon amount will be 37.5. So the number of moles will be 37.5 divided by the molecular mass of carbon, that is 12. So carbon mole is 3.125. Hydrogen we have 8.8 gram in 100 gram, divided by 1. Molecular formula, it will be 8.8 moles. Oxygen 27.6. So 27.6 divided by molecular formula 16. This will be 1.725 moles. And nitrogen, it's only 0.4. So 0.4 divided by 14, the molecular formula of nitrogen atom. So this will be 0.0286 moles. Sulfur is 0.1 gram. So 0.1 by 32, 0.0031 mole. And moisture, that is a water vapor present, is given, that is 20.5 gram. So 20.5 divided by 18, the molecular mass of water, 1.139 moles. And finally we have ash, 5.1 gram. So 5.1 divided by 56, it will be 0.091 moles. So we have find out all the mole of elements. Now we can represent in molecular formula. And water also we can further simplify, because water contains oxygen as well as hydrogen. So 1 mole of water will have 1 mole of oxygen. So that means 1.139 moles of water will have 1.139 moles of oxygen. And hydrogen, we know that 1 mole of water contains 2 mole of hydrogen. So this will be 2 into 1.139, 2.278 moles of hydrogen atom. So the molecular formula we can write first as like this, as of C 3.125, H 8.8, O 1.725, N 0.0286, S 0.0031, ash 0.091, and moisture 1.139. But we can further simplify this, because the moisture means we have H2O. So we can add these hydrogen moles here and oxygen moles here, so that we can eliminate this H2O in this equation. So that means this is our new molecular formula: C 3.125, hydrogen 11.078, oxygen 2.864, nitrogen 0.0286, sulfur 0.0031, and ash 0.091. Now the molecular weight also we can determine. The biomass molecular weight is 3.125 into the molecular mass of carbon plus 11.078 into 1, that is the molecular mass of hydrogen atom, plus, so like that we can find the molecular weight of this biomass. So this is a molecular equation or formula. Using this we can find the molecular weight of biomass. So that will be 3.125 plus into 12, that is the molecular mass of carbon, plus 11.078 into 1, that is the molecular mass of hydrogen, 2.864 into 16, the molecular mass of oxygen, 0.0286 into 14, that is the molecular mass of nitrogen, 0031 into 32, that is the molecular mass of sulfur, and ash is 54. So we have find out this. So sorry, ash is 56, so you can take 56 here, it's not 54, it's a mistake. So if you add all these, this will be 99.8156 gram. So that is very near to 100 gram, because we are consider 1 mole of biomass, or we have assumed that 100 gram of biomass, we have taken 100 gram of biomass, that is why it is near to 100 gram. Now we have to write the equation of gasification. So typically we can use this equation. So this is our biomass molecular formula: CaHbOc NDSE ash N, and we are using steam as oxygen. So the oxidizing agent is oxygen, and in addition to that we are using steam also. So we F moles of steam plus a G moles of oxygen, and our products will be in gasification, not like combustion. We will have carbon dioxide as well as carbon monoxide, hydrogen will be there, then nitrogen, inert nitrogen will be present, sulfur dioxide, and water vapor and ash. So this is the equation and different coefficients: A, B, C, D, E, F, G, H, I, J, K, L, M, etc. So we can use any letters for this, doesn't matter, but we have to find out that unknown moles. So remember, in product side, in gasification you will have carbon monoxide also, but in combustion this was not there, only carbon dioxide is there. Similarly hydrogen will also present, but in combustion we will not does not have any hydrogen, we have only water vapor in that case. So this is a, and sulfur is present, so sulfur dioxide will be there. If sulfur is not present in biomass, this will not be there. So like that we can write the equation, and in this we are assuming nitrogen as inert. That is almost true, because nitrogen reacts with oxygen in very high temperatures of more than 1500 degree. So most of the case we can assume that nitrogen in biomass will remain as such. So here we can see d moles of nitrogen atom is there, so d by 2 moles of nitrogen gas will be present. Now we have to write our equation. This is our molecular formula we have just calculated, and other things are same. Now we have to generate a number of equation by balancing different atoms on both sides of the equation. So first, balancing carbon, what we will get, that is A is equal to, right side we have H plus J. So A is equal to H plus J, but A is 3.125. So our first equation is H plus J is equal to 3.125. That is by balancing this carbon atom on left side and right side. Next we can balance the hydrogen atom. So hydrogen atom, what is left side, we have 11.078, here we have 11.078 plus, here we have 2F in steam, so 2F, and right side we have 2I here and 2M. So that will be 11.078 is equal to 2 plus 2F is equal to 2I plus 2M. That is our second equation. Now balancing nitrogen, we does not have any more equations. Left side we have this 0.0286. That means this D will be, directly we can find out, it will be 0.0286. Then balancing oxygen, we have a very, most of the term contains oxygen. So first term we have 2.864 oxygen atom, plus here we have F moles of oxygen atom, so plus F. Here we have 2G moles of oxygen atom, so 2.864 plus F plus 2G. And right side we have equal to, here we have carbon dioxide, we have 2H moles, 2H plus J. Here we have 2K, 2H plus J plus 2K. And water vapor we have M. So this is the equation, 2.864 plus F plus 2G is equal to 2H plus J plus 2K plus M. So this is a oxygen balancing equation. Now balancing sulfur, we have only one term on both sides, that is here we have 0.0031, that is equal to K. So K is 0.0031. Now balancing ash also is directly we can write this 0.0091 is equal to N. So these are the equations. So in this we have already find out this K, N, etc., D, etc. Now we have three equations containing a number of unknowns. So we have to further use the clue given in the question. So what are the clues given in the question? So this is given, that is a mass of steam to mass of biomass. So what is that ratio? That will be, so mass of biomass we have calculated is 99.8156, or we can take 100 also, that is a mass of biomass. So what will be the mass of steam used? So 0.1 into this. So because this mass of biomass is 100 gram or 99.8156, so that into 0.1, that is 9.98, or we can take 10 also. So 10 gram of steam is used, and from that we can find the mole of steam used, that is 10 divided by 18. This is 0.555. So 0.555 mole of steam will be present. So we can directly, we are finding out the steam mole of steam used using this clue. That means our F will be, so F is the letter used for representing the mole of steam in the reactant side. So F will be 0.555. Now we have one more clue, so we can substitute that 2F. So we have one equation like this. So in this we can substitute F here 0.555. so this equation further reduced to this, that is 2I plus 2M is 12.188. so we have modified our equation into this from this F value, or that means I plus M is, so this is our one equation, I plus M is 6.094. Now we have one more clue, that is carbon monoxide to hydrogen ratio in syngas is 2:1. Now we have represent CO, that is CO is number of moles we have represent in product side, and hydrogen also we have represent using J and I. So this means J is equal to 2I. So J is equal to, that is the J is the letter used for representing the number of moles in carbon monoxide in the product side in that equation, and I is the number of moles used for hydrogen. So this means our J will be equal to 2I. So this is another clue. So that means we can simplify that another equation, H plus J is 3.125. We have this equation. In this we can replace J by 2I, that is H plus 2I is equal to 3.125. So this is another equation in H and I. Now we have one more equation like this, C plus F plus 2G is equal to 2H plus J plus 2K plus M. This was the balancing of oxygen. So in that we can substitute F value, G value, etc. K value, all these things we have known. So we can solve this further, and simplifying we can write 2H plus 2I plus M is 11.211. So this is another equation in HI and M. So we have three equations containing HI and M, and simply we can solve that by using calculator or by mathematical method. We can solve this equation 1 and 2 and 3, which contains the unknown HI and M. And solving this we will getting H is 2.37, I will be 0.377, and M is 5.717. So that is our final values for all the unknown moles. So here the trick is, first you have to write the balancing equations, then use the clue given in the question, and further simplifying that equation and find out all the unknown moles. So that means our product will be having CO2, H moles of CO2, that is 2.37 moles, I moles of hydrogen, that is 0.377 moles. Then carbon monoxide we have 0.754 moles, that is equal to 2I, J is 2I. Then nitrogen already we have find out. Sulfur dioxide also we have directly find out 0.0031 moles. Then water is M mole, that is 5.717. So we have find out all the moles of this syngas composition. And remember, while taking this we are does not have to add the ash, because ash is present in solid state. So one thing you have to notice is in the product side we have a number of gas like this, carbon dioxide, hydrogen, water vapor, all these are gaseous state plus ash. And while calculating the syngas volume percentage, we does not have to take the mole of ash, because that is in solid state, and that will be at the bottom of the gasifier, not carried by the syngas. So you have to add this total moles of all the gas present in syngas. So add all these, we will get 9.235 moles, that is a total mole of syngas. Now in that you can find the volume percentage of individual gas, that is our required result. So composition of syngas in volume percentage will be, so carbon dioxide will be 2.37 divided by total mole of syngas, that is 9.2354 into 100, 25.66 percentage. Hydrogen will be 0.377 into 100 divided by 9.2354, 4.1 percentage. Carbon monoxide 0.754 into this 100 divided by 9.2354, 8.2 percentage. Nitrogen, so nitrogen is this much small amount only, because we are not taking oxygen is used, not the air. If it is air, we will have a large mole percentage of nitrogen. So here it is only 0.155 percentage. Sulfur dioxide is also very small, 0.034 percentage. And mainly we are water vapor around 61.9. so this is the overall volume percentage. So you can see here in this a majority is water vapor, and we have very less quantity of hydrogen and carbon monoxide. So that means why this hydrogen yield also we can calculate, that is hydrogen atom in syngas divided by hydrogen atom injected. So hydrogen atom in the syngas is 0.754. Hydrogen atom in the feed, that is injected, means hydrogen atom in the biomass, that is only 11.078. So that ratio is known as hydrogen yield. Hydrogen atom in syngas divided by hydrogen atom in the biomass composition, that is hydrogen yield. So hydrogen yield in this problem will be 0.754 divided by 11.078, that is 0.068. Similarly, we can find out the CO yield. CO yield is carbon atom in the formed CO, that is in the syngas, what is the carbon atom present in carbon monoxide divided by carbon atom in the biomass. So carbon atom in the syngas is J moles, that is 0.754 divided by carbon atom in biomass is 3.125. so this carbon monoxide yield is 0.754 divided by 3.125, that is 0.241. so we have also find out the hydrogen yield and carbon monoxide yield. So hydrogen yield is this hydrogen atom in syngas divided by hydrogen atom in biomass. Similarly, carbon monoxide yield is carbon atom in the CO and carbon atom in the biomass. Now why this is low? Because we can say that we have supplied more oxygen, that is biomass to oxygen ratio is very high, 1.25. Similarly, steam also is high, so reducing this oxygen to biomass ratio as well as reducing the steam, we can improve the carbon monoxide and hydrogen content. So that is the conclusion we are getting. So in this syngas composition we have high percentage of water vapor and carbon dioxide. So that is due to the high amount of oxygen supply and water steam supply. So you have to reduce steam supply and oxygen supply for getting a very good syngas composition. So that is the inference we are getting from this problem. Now we have another one more problem, that is in a biomass gasifier the airflow rate and fluid flow rate. Airflow rate is 10 normal meter cube per second and biomass feed rate is 8 kilogram per second respectively. And biomass does not contain any sulfur, nitrogen and chlorine. The syngas contains 40% carbon monoxide, 2% carbon dioxide, 30% hydrogen and methane 5% and ethane 2%. Calculate the rate of production of syngas in normal meter cube per kilogram of biomass. So this is a typical problem in biomass gasification. So in that what we have to find out is the syngas production in normal meter cube per kilogram of biomass. And the data given is biomass feed rate in kilogram per second is given, and another clue is we are using air. So this is air gasification. no oxygen or steam is used, air is used, and its rate is also given. So normally, and we can find out this syngas by balancing the nitrogen. So in nitrogen means in the air we have nitrogen, 79% nitrogen, air is used here, its flow rate is given, and product side we have nitrogen, product side we have nitrogen, but that we have to find out. So this is the equation used. Syngas production in normal meter cube per kilogram will be air flow rate into 0.79. That means we have to find out a nitrogen gas in this particular air flow rate divided by 1 minus all the other gas, so that we can find out a nitrogen gas into the feed rate of biomass. So this is a equation used for finding out the syngas production in normal meter cube per kilogram. This is by balancing the nitrogen used in air and the nitrogen in the syngas. So nitrogen, for finding out the nitrogen in syngas, we have to use this, because it is not directly given. We have to consider the remaining volume as nitrogen. So nitrogen volume will be 1 minus volume of CO plus volume of CO2 plus volume of hydrogen plus methane plus ethane divided by 100. And in the air flow rate is given 10, but in that 0.79, 79% will be nitrogen. So we have to multiply it by 0.79. So substitute equations: air flow rate 10, 0.79 divided by 1 minus these values into 8, that is the biomass feed rate. So we will get 4.7 normal meter cube per kilogram of biomass. So this is the syngas production in normal meter cube per kilogram. So in this type of problem we are solving by balancing nitrogen in air and that nitrogen in syngas. So we are to use this equation. So with this we are stopping this session. You can do more problems on gasification by yourself. Thank you.